Okay, carrying on with the sample paper, I don't want to take too long about it, so I just want to give you some hints. For the C business, one component to consider when evaluating statistical based reports is the funding for the research. What we're looking at here is what someone has to gain from this. What's their hidden agenda? Or not so hidden agenda. Explain if funding for the research is a potential issue. So we're looking at things like bias. Is it that you want, the person paying for the study actually wants a certain answer for that study, or they're using the study to promote their own product? So I want to talk to the answers on this one. The study was funded by, so you can use the actual language here. The study was funded by that particular company. It sells products concerned with internet security. Okay, so I hope I've got a pen back. Sorry. The survey is about concerns about using digital technology, in particular internet-based activities. So it's wanting to sell internet security, and it's surveying about downloading illegal music and educating teenagers about using the internet responsibly. A desire to encourage parents to buy their products could motivate AVG to produce findings that suggest the internet is unsafe. Okay, so why are they doing the survey? When you ask this sort of question, that's what you've got to be looking for. Now, to pass this question, a link identifying between the funding of the research by the internet-based company and the survey being internet-related activity. So the funding and the survey. Okay, what's the company got to gain? All right, so be suspicious. The link between the funding and the research by the internet-related company and the survey being about internet-related activity is explained in terms of the possible motivation for results. So if you think, what's in it for them? What's in it for them? Okay? Think in those terms, and you should be able to gain some easy marks. Okay, cat owners are more likely to be single. Really? Hey, straight away, this is the explanatory, and this is the response, and this is actually making some kind of a claim. Okay? So that heading has already got an explanatory, owning a cat, the response being single. Now if we go down, let's just check if they ask you what's the explanatory and what's the response. Maybe not. Confidence intervals and everything. No, in this one they don't. Maybe they're more likely to do that when you're actually doing an experiment, because you can't make a claim on an observational study, or you've got to be very careful. So this is an observational study because they're actually not changing anything. They have no control over it, they're just collecting information. But they don't actually ask you if is this an observational study or is it an experiment. So that's be prepared for anything really, isn't it? Okay, so what can we say to this question? Additional information. Farina, New Zealand is a manufacturer of dog and cat food. The survey was conducted with only cat and dog owners. For every 5 cat owners, there were 3 dog owners. So this is ratio. So this one you need to be able to use some basic year 9, year 10 maths. Identify the target population for the survey. Well, they've just told you that, haven't they? Cat and dog owners in New Zealand. You can check here, the target of the survey is New Zealand cat and dog owners. Right? So that's reading. The survey describes some key characteristics that the sample of 400 respondents should have, so that this sample can be used to make inferences about the target population. So we need to know about randomness, randomly selected. We need to know representative. So there's some generic answers that you can do. When it's representative, if we here have got our 400 and we times by 5 and divide by 8, we're going to have 250. And if we take 400 and times by 3 and divide by 8, we should get 150. So 250 plus 150 is your 400. 5 plus 3 is 8. So I've just taken 5/8 of 400 and 3/8 of 400. So I should have 250. So 250 to 150. I should have 250 cat owners and 150 dog owners if I was to get it properly representative. Going back here, the ratio of dog and cat owners should be around 5 to 3 in the sample. So that's what I was on about. Okay, now there's more things to think about here. We did the randomness of all cat and dog owners in New Zealand, and it should be representative. So we talked about randomness and representative. This is just better language. The sample should contain cat and dog owners from both rural and urban areas of New Zealand, and proportional to the number of pet owners in these areas. Also, other things to consider would be making sure that if you've got owners that have many cats and dogs, that they're proportionally represented as well. So there's other answers. That's fine. Okay, let's keep going. One component to consider when evaluating a statistically based report is the exact questions asked. Identify potential difficulty when asking a question, keeping to yourself. What does that mean? It's actually open for interpretation. So they would have to define keeping to yourself. Does keeping to yourself mean you only go out 3 nights a week? Or does it mean that you go out 3 times a year? So really, it's not very specific. And if you're at home, do you have friends over? So how many people do you normally have contact with in a week? For example, someone might say they keep themselves, but work with 200 people every day. And so at home, they keep themselves. A clear definition of what keeping to yourself means would need to be provided for people working it out, filling it out. Otherwise, you're not going to get a consistent response. Could the claim that a higher percentage of cat owners prefer to keep to themselves than dog owners be supported by evidence presented in this report? Construct a confidence interval and interpret this interval as your answer. You can assume that within the sample of 400, for every 5 cat, there's 3 dogs. So we said that's going to be 250 to 150. So we're looking at a difference. So we're going to go percent of cat owners less dog owners. So let's go back up and find those percentages. Okay. So 80.5% of dog owners were either married or in a relationship, while 60 of cat owners. Okay, so which one are we more interested in a relationship or what? Are we looking at the single ones? 30% of cat owners were single compared to 14.6% of dog owners. So we need to read the question carefully. Keeping to yourself. Okay, let's try and find those. 63% of the respondents identified as cat people. Whoa. Got to read carefully. About 61% of cat owners said they preferred keeping to themselves, while 53% of dog owners. Okay, so we need to go 61 less 53. So, whoops, get back down. Percent difference, 61 less 53, which is 8%, and the margin of error equals. We're comparing two groups, and we've got we go 1.5 times the average margin of error. So the margin of error for the cats is 1 over 250, the dogs is 1 over 150. So we need to add these two together and divide by 2. So I'm just going to do that in my calculator, clear. So I'm going to do a bracket, 1 divided by 250 to the power of 0.5 plus 1 divided by 150 to the power of 0.5, divide by 2, oops, okay, maybe I can't have spaces. And we're dividing by 2, okay. So then we need to times that answer by 1.5. So I've got 10.9%. So we've got 10.9% is my margin of error. So I'm going to have 8% plus or minus 10.9%. So the margin of error is too large because it's going to go negative, and so it's too close to call, or I cannot, it does not support the claim. So we've got this one, average margin of error times by 2. We've got our 8 percentage points, and we've got the negative in there. So you've got a standard statement there if you could use if you wanted, or you could just use that one there. And so the big idea here is actually evidence presented in the report could not be used to support the claim. Okay, because the margin of error is greater than the difference in actual fact.